Hey everybody, this is Larry. This is day 17 of the Legal Day Challenge. Hit the like button, subscribe button, join my Discord. Let me know what you think about today's poem. Today we have a hard poem, but before we start, we'll do a little bit of chat. I ran my 12 mile today, 10 of it at Meltdown pace, and it is a mess. It's a little bit chilly outside, but a lot of wind, but just gonna get going. Like it was just, I don't know. Maybe it was the fact that I ran like 60 something miles last week and a lot the last couple of days. So like you carry along all the tiredness and fatigue, and maybe I don't know. But definitely my body just didn't feel up to it. I did finish it though, so it's good. But and I don't want to dwell on it too much. As it is part of it, part of the training. The marathon, excuse me, the marathon is in 2 weeks, 2 days. Wait, is that true? It is, which is ridiculous. Oh man, saying that out loud is a little bit scary. But yeah, I think the thing that I want to relate is that like last week, I if you watch, especially you could watch back that video and how I described it. But last week I ran 13 miles, or a half marathon actually, distance, and I ran it faster. It was more effortless, and I had a better heart rate, like throughout the thing. So I don't know. So it kind of feels weird to have a regress, especially since today, the weather was, well, it was very windy. So like it was cooler, which is good, but it was windy. So and it was like against me, right? Like headwind. So like I feel like I was running a little bit too hard. Like I was running my paces, but I was running too hard given that like I was trying to hit my paces, but the wind is against you, so you have to run harder to hit the same speed, right? So I think as a result of that, I tired myself out too early. Maybe I hope that's it. Honestly, I have no idea why. But that brings me back to Leetcode, right? I think one thing that I talked about, I don't remember when. I think like maybe half a year ago. But maybe I still have it up actually. Maybe I can find it. But yeah. Yeah, but basically Des Linden, one of the greatest American marathon runners, um, you know, basically shared a comment from, I don't know, like 10 years ago now, maybe something like that. Um, but basically the story is just this, right? Like, um, even for her, she basically just says that like she doesn't know which version of her will show up on any given day. Some days are good, some days are bad, and I feel the same way. But the thing is, you still just, I mean, the only thing that you can control is you got to show up. And that's it. uh I actually did, like I said, I actually was able to successfully run my workout. But if I had failed, I still rather fail out there on the track, on the West Side Highway, on the mile run, rather than failing on the couch, not getting out there, right? So that is a choice that you can make. That is that is something that you do have the power to control, and that's it. All right. Whew, I'm very tired. I'm not gonna lie, because like I said, I just ran 12 miles and it was a very tough 12 miles today. Uh, 2 weeks and a couple of days. But yeah, let's take a look at today's problem. We have 3003. Maximize the number of partition after operations. You're given a string S and an integer K. Okay. First, you're allowed to change at most one index in S to another lowercase English letter. This is a hard problem, by the way, so hopefully not too hard, because I want to go to bed and sleep, or even if I don't sleep, just like rest. But anyway, after that, do the following partition operation until S is empty. Choose the longest prefix of S that contains the most, at most, K distinct character. Delete the prefix from S and increase the number of partitions by 1. What does partition mean? I mean, huh? All right. Maybe I don't know what increase the number of partition mean. Oops. Click on. In any case, all right, we'll see. The remaining characters maintain their initial order. Return integer denoting the maximum number of resulting partition after the operation by optimally choosing at most one index to change. Okay, maybe, I don't know. First, I just want to look at the constraint, right? It's going to be 10 to the 4th for n, and k is 26 is maybe interesting. I forgot what k is, honestly, already. Oh, 26 unique characters. Okay, I mean, that makes sense because there's only 26 distinct characters anyway, right? So, okay. So, choose the longest prefix of x. So this is not a choice, right? I think. Yeah, it doesn't sound like a choice. And then I think this is just a really weird phrasing. That's why I'm a little bit confused. Because they could have just said partition the beginning, right? And then now you have one more partition. Like removing it and then just increasing. Like that's not even, I mean, you could call it a partition, but you could just also call it a count or a number, right? Like it's not a, like when you remove things, it's not a partition anymore. It's just removed. All right. Terminology aside, I think I understand what they're saying. Let's take a look at some examples because I get what they're asking. I don't know, or I think I do, but I mean, it's Leetcode and it's me. Who knows, right? All right. So this one, I wish they have one where they just don't change so we can go over it. Okay, you change S2 to B, and then now K is equal to 2. So then you have AC, BC, and then A. The string is divided into 3 partitions, so the answer is 3. Okay. Yeah. Maximum number of, okay. K is equal to 3. You could always choose all of them because, yeah, okay, makes sense. K is equal to 1. So, okay. These are pretty basic examples, and I actually like, I know that I've been kind of crapping on different examples recently for understanding reasons because, like, I mean, I talk about it. Like, what? Give us examples that show us our understanding, not like, like it should not be a problem reading contest. It should be a problem solving thing, right? Like work on your problem solving, not problem reading. But in any case, yeah. And of course, during an interview, you would just ask questions, but which we can't. So that's why I give them crap. But these are pretty good in explaining what this is. So I feel like I'm happy about that. Okay, so I think I get it. And okay, so the first thing that you might think about is just a naive solution, which is n squared, which is going to be too slow, right? But the idea behind the n squared solution is just, and maybe even n squared times k, or not even k, but yeah, just like, yeah. But like one of the other characters, and that'll be with brute force. It'll be n squared times 26, and that's definitely too slow. I think the first observation that and that's why I paused. So, I don't know how to solve. Just to be clear, yeah, I don't know how to solve this yet. I don't know the solution yet. It's a hard problem, so I'm not quote flashing the problem. So I am working it out with you. So hopefully, we'll work through it together. But my first observation, and this is why I paused when I was talking about and I was trying to. Because I am trying to solve it and also explain it at the same time, which is obviously tough. But that's the point of this channel and these videos, is so that you could see how I attack these problems live, and not the perfect version of the video of like the explanation. I want you to see how I attack the problem, incorrect or correct, right? Or incorrectly or correctly. That, I guess, is an adverb. But anyway, I think the first thing that I notice is that, okay, if k is 26, then obviously it's just, doesn't matter, right? But if k is 25, for example, then that means that you can always choose one, you could always choose a character that isn't represented, right? And what I mean by that is that, like, for example, you don't even, for this one, I mean, k is equal to 2, but you don't have to change it to, like, you don't have to test changing this character to B or D or E or F, right? Because they're all the same in the sense that all you need is a different one. And if k is 25, then you could find one that is different, right? By pigeonhole, because it's just, so you don't have to test that. And that already optimized your thing from 26 times n squared to just n squared, which is still too slow, of course, but that's just an observation, right? That when you have a window, then you could use, quote unquote, use this. And of course, this idea that now is that I mean, I think I know how to solve it, just to be clear. But I want to be able to think about how to explain it. But I think I think the thing that I want to think about right now, if I didn't already kind of jumped ahead a little bit, my apologies, is that, n squared is too slow, so we want to do something maybe O of n, or maybe even n log n, or something obviously faster. The thing that you can try to do is try to quote unquote save work down. Why did I say it in that intonation? Save the work down, right? So that we don't do duplicate work. And then as a result of that, it seems to me that you could do dynamic programming, right? And there are a couple of ways you could frame it, but the idea here is that, okay, you have some, you basically given a string. Given a string, the states are kind of okay, right? Because when you partition something out or chopping it off the beginning, it almost as if you're just solving on the suffix, meaning that whatever you have now on that suffix does not impact what you have on the prefix, kind of, for the most part, right? Because, yeah, there's no change. The only thing that can change, the only thing that impacts, the only thing that's lingering is this idea of changing at most one index, right? So then the thing that you might do then now is that, okay, well, we know that every suffix we can try to find the answer. So then now maybe we have, the index to suffix starting at index, right? And this is the best answer. I've been calling everything f lately just because, it's like a function. Like, I don't know. It's just easier to remember. Well, not remember, but easier to not think about it, because I've been really bad about naming things. You could say like get max or something. I don't know. Anyway, but then the other thing is used, right? And used is a boolean. Boolean showing whether we already changed a character, right? Okay, we could even, I don't even know if this is necessary, but we could already just say, like, if k is equal to 26, then we just return 1, right? Yeah, because you have one partition. And you could even, like, simplify it a little bit, right? You could even just write, like, if k, and this is maybe whatever optimization is equal to greater than or equal to the length of the set of S, then we return 1, right? Meaning that if k is bigger than the number of... Wait, is that true? Well, maybe that's not quite true, right? Because you could still choose one that's outside. All right, well, we don't need it. We'll just... the thing with premature optimization is that, don't try to do it. I think that's the short answer. But the reason why we do this is maybe it's just a little bit cleaner for the edge case purposes. That's the real reason. It's not really for optimization. It's so that we don't have to take account the k is equal to 26. Because if k is 25, then, like I said, by pigeonhole, you can always find, you could just pretend, like instead of denoting a character, you could just use a character, right? Okay. So, okay. I think I'm wrong a little bit. Oh, rather, I think I have to do one more thing. But I have to think about it. Because the thing that I was going to write is that we could maybe, and this is where I messed up anyway. Maybe we could write like, okay, well, how many states are there, right? Right, index can go from 0 to n, and use is just true, false, or 2, right? So then this is O of n number of states. But then I was about to write a for loop, right? Like for to go extend, right? So like for I in range of I don't know, n. Huh. Like I is you go from index to n or whatever, and then you do some magic here, right? But the problem is that now each state does O of n work, and so then this is still n squared, which is obviously not what we want, right? And so how can I solve this? I'm trying to think whether I think one observation maybe is that a lot of the states are not possible, but I have to try to think if I could prove it. And what I mean by that is that keeping in mind that it is not. Oh, I see. That's right. That's right. I think I confused it a little bit. No, I think this is fine. I think the one. I mean, I'll do some optimization as you see, but but what I was going to say is that, well, one is that we can pre-process this, right? But not all the states are possible because everything is forced, right? This is not a, I mean, this is a for loop, of course, and maybe that's the way that we can use to calculate it. It doesn't have to be, but it really just is that we do recursion on, replace one character and then not replace, right? And then now if we replace one character, maybe it gives you some new index, right? And then use this to go true. And then another one is not replace is a second new index, I suppose. But then we still just we pass along the used, and then we get the max of those two, right? And then the question is then now, how do you get the new index? And my initial thought was, well, just run a for loop. And maybe that's fine, but we can do a little bit better, right? Yeah, what we can do is use a sliding window, right? We can do it inside here, right? That means that we cannot use it here. What we can do is pre-calculate it for each index, and that's basically what we'll try to do, right? So we have left is equal to 0. Oops, that's not a 0, right? In range of n, right? And then now there are two things that we have to do. We have to do a sliding window for this is used and when it is not used, right? So that we can use it. And the sliding window is pretty, I wouldn't say straightforward, but it is a problem that also for whatever reason Leetcode has a variation of this, which is that, like find the longest sub array in which you have like k distinct at most k distinct characters or something like that, right? So that's definitely a very popular Leetcode problem. So definitely, yeah. And because keep in mind that you have no choice, it has to be the longest. So you just keep going until you can't go anymore, right? So okay. So then now maybe we have some scene type thing. We call it counter, right? So then scene of s of right, we increment, right? So then now right is inside. And then now we want to say, wow, length of scene is greater than k. Then now left increment by 1. But before we do that, we remove this, right? Yeah, and that's basically it, kind of. I say kind of because it's not quite right. Because the reason why this isn't quite right is because, this is how you would normally do it, and this is right for what we want to do, but we cannot use it in an easy way because now you have left and right, but it is unique on the right, Where here the function input is going to be the left side of the subsequence, right? Where left, not every left is represented, even though we want to. So we would have to rewrite this, and I kind of maybe just mentally templated it, even though it's not. I don't know if you want to call it template, but right. And also, this isn't quite correct, just because I have to write something like if you really want to be precise, or precise and actually working, something like that, right? So then now the length of the scene can actually be less than k. But like I said, this does not allow us to keep going, because here inside this loop, that means that this left, from left to right inclusively, there's more than k objects, right? Which is not what we want. So okay, so then how do we have to rewrite it? I mean, I think it's just the same idea, but yeah. Okay, so then now we want No, I mean, I think this is the same idea, but written a little bit differently. Right. So then now, while the length of scene is less than k, right? We have to do some things to make sure that, like, for example, right is less than n, and this, then, you know, then now left maps to right, right? So then now maybe we could have an index of, like, I don't know, I'm just gonna call it lookup, because I'm lazy. Maybe we could rename things better, right? So then now lookup of 0 is gonna be right, right? And then now we can yeah, we can now do for left in range of n, and then now we remove left, so then scene of s, well, basically this part, right? And then now you want to keep track of the invariant, which is that we want to keep on going while right is greater than n, and length of scene is less than k. And also, this doesn't have to be I mean, it should be an array, right? Because there should be no gaps. So yeah, okay. So while this is true, then we right? Okay, so that's basically the idea. So that's for we not using changing a character, right? So how can we change a character? The thing that we have to keep in mind, and I'm just maybe talking to myself, maybe you already know it, is that changing a character and also, yeah, just to be clear, this is linear time, linear space. So then now we can just say, if we don't replace, then just look up of index, right? So then now, and this is actually it. So it's going to be 1 plus this, and this is going to be 1 for not replace. But then now we have to figure out how to do replace character, right? If index is greater than equal to n, then we return 0 because we're done. Now we have to replace one character, right? And that's a little bit trickier because we have to remember that you only replace one character. And maybe that's obvious, or maybe you already know what that means. But what I mean is that it doesn't mean wait, let me relook at this. We want to make it so that it goes bigger, right? So then what does that mean? Maybe I'm simplifying it too much and I'm not clear on this. What does replacing one character mean? Well, we want to, or like what I'm trying to figure out is whether there's a greedy way of doing it, right? And what I mean by that is that, okay, you have A and C, and then now you have another C. Oh man, my toe blister just popped. That's actually kind of disgusting. But that's actually very disgusting. Sorry, I ran a lot lately. Got Band-Aid. Okay, so like the question is, when do you use the character? If like it, is there a greedy way to do it, right? And like I said, maybe it doesn't matter. Maybe we just, well, maybe I have to think about this a little bit. Because I just assumed that you can greedy it, but maybe that's wrong. Because here, for example, just you look at the prefix, like, can you choose A? I mean, the thing is that, like, we don't want to try all of them, right? Because then it's just O of n squared. So we have to be a little bit smarter on choosing which one to replace. Huh. I mean, is there a forcing function like AC? But like, here we want to remove the C, but what if... Okay, maybe that's fine then. But I don't know that you could do sliding window in an easy way. That's what I was going to say. Right? Because here in a greedy way, you could say, okay, well, C is dupe, so, and if K is not, you go to 26. Then we can always choose this to be a, quote unquote, a fake character to give you one extra thing, right? And that's fine. But then how do you slide it, right? Do you need to slide it? Is there assumption that... I think... I think there is like a YOLO idea of having a for loop to do it in a greedy way, given this index. And the reason may be that it's just a lot of it is not possible, right? But that's like a way. That's why I call YOLO, is because that's a way like I don't know. I mean, I don't have a good proof for that right now, right? Because then it could, in theory, could degenerate to n square. What am I missing? I feel like I'm missing something. I mean, I would also say that if this was a contest, I would definitely YOLO it. And some of that is just by experience and feel. And also, I could be wrong, but if it takes me longer than 5 minutes, which is the penalty for doing it that way, then it would have already been worth it to discover it. But maybe this isn't the way to do it. Maybe this is a bit mask problem, isn't it? Yeah, okay. I think that's the... I mean, I'm gonna YOLO this just to see if I can, but I think it is a bit masked now. But that's. Yeah, okay, fine. I accept that I messed up. But I am curious though. The first. Yeah, I mean, yeah, we'll try it. Why not? But cup of I, right? Oh, it's if not used. If not lookup. What's it called? S of I. If it's in scene and not used, used is equal to true, and then we continue, right? Else we just do this, right? And if scene or if length of scene is greater than is greater than k, I guess this is actually and actually maybe the way I should write it is we'll just add like a fake character. I am curious whether this is fast enough, but yeah, if this is greater than k, then I makes it go over. So then now we can go f of I, true, 1 plus this, and then we break, right? And then that's it. But I'm not, like I said, I don't know if this is right, but I always forget about bit masking. We'll YOLO it for now. The idea, hopefully, is that there are not that many states, and so you only want that for a limited amount of them. But we'll see whether this is fast enough, or even correct enough. Since we do utilize greedy, the answer is 4. Oh, K is 2. Okay, so then now we do. So now 1, 2, 3. Why is this giving me 4? How or what is the partition that's giving me 4? 1, 2, 3. I don't know. Oh, this is I plus 1, so maybe I was double counting. But then now this is wrong. It should be I plus 1, right? Because we used. Oh no, I is making it go over, so we use I. I think that's right, actually. Yeah, I think this is the right idea, but or the idea that I want to represent. Whether it's right or not, that's another story. Man, today I'm bad, but I am, learning, I suppose. The 26 should have gotten me, but okay. Why is this wrong again? All right, we'll just print it out. I guess that's because I reused used for no reason. Uh, okay, fine. Alright, so it was 4 because it jumps to 2 true, false. No, but so it goes from, so this is 2 true, false, which means that we're at B, and we skipped for some reason, right? Did I mess up? No, the answer is true. True means that we took this path. Oh yeah, no, that's right. And that, let's say we turn this to an F, right? Then now this is 1, 2, right? And now you have this thing. But this is returning 3, even though that's wrong. Because this should have been, oh, this is right inclusive. So this means that this is inclusive. Excuse me, so I think I just got it off by 1. But then now the other stuff is wrong, which is not great. Expected 3. Why 0 force is 2. Oh, because this adds the new one here. So then now, okay, let me see if I could deal with that. Because the reason why this is failing is because we add, if this is the last character that makes it go over, then now, that's a very tricky thing to fix. Because we're trying to do the case where we change this, so this is now a new character, right? So we already used. I is the thing that made it go over, but I is the thing that's used. So then maybe we could do I plus 1 if it's used, because that. Yeah, I mean, I think that makes sense. Okay, but that's a little bit awkward. I just want to get, I know this is not the right way. If you really want to know the right way to do this, fast forward. But it is more for myself than anything. And I'm curious whether there's a way to make this work. Just exploring a different way. I definitely messed up though. That's still not good. Oh, no, this is right. In theory. Oh no, in that case we have to make K smaller. That's annoying. It's possible to do, but it's just annoying. Huh. I mean, I also don't have any idea whether this is fast enough, to be frank. But though I do wonder whether I can fix it. I mean, the short idea is just to add another state for beginning, right? But then now this messed this up because now the lookup index assumes that this is K and not whatever. All right. I don't know. This is not the way to do it. But yeah. The other way is kind of annoying, and I don't know why. I mean, it's not that annoying. I could solve it pretty quickly, but I don't know why people like those kind of problems. But okay, so the idea then now is just that we keep track of, I mean, the same thing, right? But now we want to, instead of what we did before, we have this thing where we have a jump table, right? Of, okay, well, we're just doing one partition at a time. Here, what we want to do instead is instead of doing one word at a time, we just do one character at a time. What would it look like if we do one character at a time? Well, that means that now we have states, right? And we have this, well, used is, okay, let's actually rewrote our thing. Index is the suffix to self for, right? Used is whether we use our one thing. And then maybe I have another thing which is seen, I don't know, which represents a bit mask of characters is in the current partition, right? Yeah, I mean, it's fine. The tricky thing about this part is that we do like number of states. Index goes from 0 to n. Used again is true, false, so 2, right? But seen, you know, there are 26 characters. It could go to the 26th time, right? Or to the 26 states. But not all of them are possible. The reason why that is the case is, and we'll do a drawing right here. Yeah. Hang on. The key thing to note is someone keeps telling me the name of this, but I don't know it. Some like, because when I learned this, or I don't know if I learned this, to be frank, in the sense that like I think I just came up with, I mean, obviously I didn't invent it, but when I saw this for the first time, like I just kind of proved it to myself and came up with it. So I don't know, I don't know, and honestly that because I'm self-learning that way, I don't know a lot of like official names. And slash back in, like for example, what is it called, like sparse table, for example, I learned it before it had that name. All right, let's get clear. I am old enough that you know that name came after I know how to do it that way. So a lot of stuff I don't have name, but basically for this problem, right, we have A, B, A, C, C, A, or whatever. Let's just say, I don't know, right? The idea here is that, okay, let's just keep track of the bit states, right? And we'll keep track of the bit states. We'll go over the set a little bit, but or what a bit mask is, which you may be a little bit confused about. But the idea is just let's keep track of the prefix, right? Okay, let's say we have A, right? So then now the prefix is going to be A, AB, ABA, ABAC, you know, dot dot dot. Maybe that's not even the way I want to explain it. Okay, let me try again. Instead of doing the prefix, which you can just see, let's do the set of characters that goes with the prefix, right? And what I mean by that is that we have A for this one, and then for the 2 character, length 2, it's going to be AB, 3 is going to be AB, because the A is a dupe, 4 is going to be ABC, 5 is going to be ABC, and dot dot dot, right? The key thing to note is that this is additive, right? Meaning that once you add a character, it doesn't go away, right? And what does that mean? What that means is that if you kind of look at the progression from going from left to right, and let's just say we're only keeping track of this index, right? Or starting at this index, going from left to right, or maybe the other way is a little bit cleaner because it is the direction of the DP. You know, maybe going from left to right as the input. So now instead of looking from the prefix, we're going, okay, well, let's say we're at this character C, and there are only a number of possible inputs, right? We could, well, just do what we just did, but again, the reason why we look at the number of possible inputs is that, well, now this is going to be C, right? 2 characters is going to be C. 2 characters behind. 3 characters is A and C. 4 is A, B, C. And then 5 is still ABC, and then, I mean, I'm going to dot it, even though there's nothing to the left. But the idea here is that now, if we kind of look at all the possible input that ends at this input, at this character, it's going to only be additive as well, right? Like it can only increase. And then the question is, well, how many possible prefixes are there? Well, because here for this problem, we can't skip anything, right? It's prefix, everything is forced. So as a result, like taking this and then this and then this and then this, because every new index has only two things it can do, right? There's only every new prefix to the current substring can only do two things. One is it doesn't change it, right? Like for example, for example, these two, it doesn't change, right? It doesn't change. It is what it sounds like. But if it does change, it only adds one character, right? And then as a result, if you kind of think of it backwards this way, that means that because there's only 26 alphabet, but you can also even just represent it in terms of K because K is bounded for this problem. But let's just say 26 for now. That means that it can only change 26 times. Or another way to say it is that given this index is the input, there are only 26 possible bit mask or 26 possible of these previous used characters, right? And that's basically the idea that we have for this one, that we have to abuse, that we have to use. And yeah, and you can maybe even, if you want, just to make things a little bit easier, you could just write count, but it doesn't really matter because you could write something else, right? Okay. So then now, I mean, we'll go over it again. I might have gone down a little bit fast, but yeah. But the idea then now is that we just do tick, no tick, right? Well, I say tick, but what I mean by that is use a new character. And then here, don't use a new character. And don't use a new character is pretty straightforward. Oh, let me go over bit mask for a really quick 20-second bit mask lesson. Because I think people make a big deal of it because it's just like bits and then you see crazy operations and stuff like that. But bit mask, maybe I need to do a short or something so that, it's more straightforward. But bit mask is not that confusing. Bit mask, basically, you could think of this as like, okay, let's just say we have scene is equal to an array of force times 26, right? And then, and that's what we do. And we want to do operation on it. So then you maybe set scene of I is equal to true, scene of I is equal to false for some I, right? And the same thing is with bit mask. A bit mask, what is it, right? A bit mask is just a binary number, or it's a number, but it's a number that if you look at in binary, just 0, 1, a lot of zeros, 1, 0, 1s, right? And then here, 0 is equal to false, 1 is equal to true, and that's it. And you could use it however you like. And then now, instead of scene sub I, you may write something like bit mask and 1 sub I, because then now you could look at a 1, and then you shift it I times. Okay, I don't know. This is very like manual animation or something. But yeah, you shift it I times, right? And then now if you AND it, well, if you AND it because all the other numbers here are zeros, that means that we zero out everything else. And then now there's only two things left, which is this 0 or 1. It could be a 1. And then when you AND it, it either is 0 because this is 0, right? Or a non-zero because this is a 1, and then the 2 AND is going to give you something. And that's basically just checking to see whether, what scene sub I is, right? Like, so this is read scene sub I, right? Right? And then if you want to set it to true, there's there are a couple of things you can do depending on how you want to write it. It doesn't really matter. But for example, if you want to set it to true, you could just do this shift sub I thing, right? And then you OR it, right? Like a bitwise OR. So because then a bitwise OR, a 0 turns into 1, ... A force, you do a bitwise AND or the inverted thing, right? And the idea here is that you do bitwise AND instead of something like this. But the inverted make it so that you're doing a bitwise AND with something like this, right? So then now, whatever it was before, it will stay the same, except for this one where you turn it to 0 no matter what. And then there's some like XOR things that you can do, but the core idea is just allows you to do this, and these two, but in a way that is a little bit faster, but more importantly that you could use for memcache, for me anyway, right? Or did I say memcache? Sorry, but I mean like memorization. Yeah, okay. So that's basically a bit mask very quickly. Maybe I need to do short. But yeah, don't use a new character. We don't use a new character, then we just have, so scene has a bit count, right? So, well, the two ways to do it, right? So if, so what's the current character? Current character is equal to minus right? So this just gives us the position, like A is 0, B is 1, C is 2, ... So that's what this does. And then now if scene and 1 minus, or 1, 2, if this is greater than 0, that means that not a new character to the current substring. So then we can just, you know, well, we have to do a best thing, right, to maximize. So if it's not a new character, then it's just best of max best f index plus 1. Oh, used because we didn't change it, and scene, right? Because, well, it doesn't. We don't change scene because there was already one there. Otherwise, this increases the number of unique characters. So then you would maybe write something like, you know, if scene.bit count, which is the number of ones, if plus 1 is greater than k, then we have to start a new string, right? Substring or whatever, partition, I guess is the new word, or the word for this problem, right? And then, you know, f of index plus 1. Yeah, use don't change, and then now because because we're starting a new character, a new thing, we just have one shifted by I or C, sorry, because this is just now we only have one character, right, in a new string, so that is by default, you know, gonna be 1 to C. Else continue the partition, which is best is max best f of and you could write this in other ways. You can maybe make this into a base case, for example, but it's fine, right? Continue the partition. So then this is what we said, where we have scene or 1 shift to the C, right? And that's all the cases for don't use a new character. This is just case analysis. We did a live, right? Use a new character. Okay, I mean, there are a couple of ways you can do it. Maybe we could exploit the fact that we were saying earlier, but I'm lazy and tired, so we can just brute force or 26, right? So let's do it. So then C in range of 26. Yeah. Oh, this is only if not used, right? So if we're not used, then we can brute force a new character, and then it's just best as you go max best f of index plus 1. Used scene right? In fact, you know, let's remove this base case, right? Yeah, let's remove all these base case, right, to make it a little bit easier. And then the reason is because then now we just could write it here, right? Which is if scene.bit count is greater than k, and it should be only k plus 1, but yeah, then now we can return f of index used. Oh, I guess you can't do it that way, can you? Maybe I lied, because you have to keep track of the last character you add. Okay, so I lied. Okay, fine. All right, well, mistakes were made. Yep, okay, fine. This is very annoying though. But this is basically, we do the same thing here, right? Oh, and this is a 1 plus because we started a new partition. So if this is too much, we start a new partition. But keep in mind that use is going to be true because we just used it. Yeah. Else, and we do the same thing as here, and that's it. Hopefully. Can't believe this is an hour-long problem. Oh, whoops. Well, that's a not great situation. Did I mess this up? Oh, yeah, this has to be true. Though, I mean, that's definitely a thing anyway, but, Man, today is just not my day. I feel like I've been saying that every day though. But, I am also just very tired. That's my story, I'm sticking to it. Huh, why am I undercounting? And also I'm wrong for in every case. Oh, wait. No. Okay, I think because I didn't start the first substring, so I think that's why. Alright, give it a quick submit. Hopefully nothing too wrong. Oh, come on. Alright, well, I'm too tired for this. I don't know how to debug this. Because this is just like mumbo jumbo, really. Yeah, okay, let's take a look. Sorry, I have to like recollect myself a little bit. Did I miss a... I might could clean this up, but... Alright, so then now we can write... same here maybe, but... Oh, this is just wrong, isn't it? Okay, maybe I'm just being dumb today. Okay. And you can... Okay. I don't know why I wrote... I think I'm just tired, because I was comparing with the wrong one. Yeah. I mean, this is this problem was a marathon, I feel like. What did I do last time? Oh, last time I got it right in the first try. I guess today I just... Is it the same idea? Yeah, I guess it's the same idea. I don't use this. That's why I was looking at this. I mean, this is... Yeah, okay. This is just like the bit mask pre-calculated, but I guess this is just very messy in general. Because I was like trying to optimize it, but I don't know. But yeah, I mean, it just become the key thing to note is this bit mask scene, and the idea that I was saying, which is that you have this prefix thing, even though it looks like there's a lot of states, right? But none of them are possible. In fact, for each index, only 26 is possible, right? As we said, because it's incremental, it's additive, and so forth. So then as a result, scene has only 26. And now that means that this, or technically k, I suppose. So that now it's just n times 2 times k for this one, right? Number of states, I mean, or number of possible inputs, maybe you could say it that way too. So each input does all of k work for here at most, right? You could probably be a little bit smaller, right? I don't know. So then it's n times 2 times k squared, and this is the complexity. And that's all I have for this one. Let me know what you think. I am too tired to really, I don't know, do anything. So, yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.